All right, so chapter 4, section 1 is radian and degree. It's all the basis of what we're about to talk about, which is that trig, okay? So we start with, like, what is a radian? We're going to get into converting from radians to degrees, finding coterminal angles, finding length of an arc. All that stuff is in section 1. So we start with the basics, like the parts of an angle. A lot of this is vocabulary stuff that you have to know in order to understand what you're looking for or what the directions say. So it's the initial side, which is the beginning of the angle. Okay, in this case, here's my initial side. The terminal side is where that angle ends. And there's usually an arrow to show you the direction, whether it's going clockwise or counterclockwise. And then hopefully remember from geometry, where those two sides meet is called the vertex of the angle. A positive angle has counterclockwise rotation. So if it starts, and this is called standard position. If it starts at the horizontal axis on the right-hand side, which is like a degree of 0, which we'll talk about in a little bit. If it starts there, then it's in standard position, and a positive angle rotates counterclockwise, so against the flow of the clock, to the left. And then a negative angle starts in the same location if it's standard. So this is still standard position, but it goes in a clockwise direction. So it goes around to the right. Positive left, negative right. Then we talk about radians. So a radian is like the length of a circle as if the radius was 1. So when you think about a circle's length, right? So if I asked you to find the length of a circle, what is that measurement called? Circumference. So if I give you a circle with a radius of 1, how do I find the measure of the length or the circumference? Pi, nope, 2 pi r or pi d, right? Pi r squared is area. Pi times diameter. So if that's the case in this circle, what would be the circumference of this circle? 2 pi. And if I told you to estimate pi at 3.14, you would tell me circumference is what? 6.28, right? So that's the actual length of a circle that has a radius of 1. And that is where radians are derived. So if I look at the radian measure on a circle, all the way around my circle would be 6.28, or approximately 6.28 if I rounded it. And that's how many radians are in a circle, okay? So if you're going to start to find the measure based in radians, like this is 1 radian, this is 2 radians, this is 3 radians. The easiest way to do it is to take that circle. So this is what I would suggest you do. Starting at this line here, okay, this would be 6.28 if I went all the way back around. So a little bit less than that, let's just say it's here, would be 6 radians. Now if I take and draw a line connecting that to the other side, that passes through what should be my center. Let's say it's like that, okay? Now it cut that 6 radians in half, that's 3. Take that from the 0 to the 3 and cut it into 2 smaller chunks and draw lines there. Oops. And now I've just divided mine into the second and the first radian, and then the fourth, nope, yeah, fourth and fifth. So all the way around your circle is 6.28 radians. Just a little bit shy of that would be your 6. That line goes straight across, that hits your 3. Cut that 3 into 3 parts by adding in your 2 and your 1, and then draw them into lines, and now you've got your 4, 5, and 6. So if it asks you to approximate what an angle that has 4 radians is, then I know I would start at the 0, and I would go around to where 4 is, which is somewhere in between my halfway point on my circle and my 3/4 way, if that makes sense, okay? So the easiest way to approximate it would be that. These are in radians, and these are not in terms of pi. So eventually we're going to get into terms of pi, which is totally different. For right now, it's in terms of a whole number radian. And there are 6.28 of those in one circle. Does that make sense? So the easiest way to approximate it is to kind of visualize it like that. Take that 6.28, cut it in half, divide those into two smaller parts, and you'll get your other radians. All right, so at the bottom is how you could find the radian measure if you're given, or actually how you find the angle measure if you're given the length of the arc and the radius. So that's just how you would derive radian measure, which we're not going to use for the radian measure, but you're going to see that come back when we talk about arc length. So don't worry about the bottom just yet, okay? So the drawing the angles in standard position. These are your 4 quadrant angles in radians. So eventually we're going to do this in radians and in degrees, but these are the most important ones in radians, okay, the easiest to find. So if the start is 0, if this starts at 0, then all the way around would be back to 2 pi because we said this is a circle with a radius of 1. Circumference would be that 2 times 1 times pi, or 2 pi. That's all the way around. If I cut that 2 pi in half, or I cut my circle in half, what's the value? Pi, which is your halfway point, which is going to be here. So for here all the way around to there, that's your pi. If I take 0 to pi and cut it in half, what do you get?
Pi over 2.
Pi over 2, which is a half pi, right? That's going to be your 90-degree mark. So it's straight up and down, halfway between your 0 and your pi. And then halfway between pi and 2 pi is your 3 pi over 2, or 1.5 pi. So those are the first, those are called quadrant angles, okay? Those are the ones you want to establish first. 0, pi over 2 at the top, pi on the left, 3 pi over 2 at the bottom, back around to 2 pi on the right-hand side. And again, eventually we're going to fill these in with degrees as well. Dominic?
After we take our unit circle quiz, will we have unit circle on our test?
I'll give you back your unit circle quiz.
Okay.
Yep. We just don't have time to fill it in again. All right, so then this says draw and label each angle in standard position and state which quadrant the angle lies in. So go ahead and try to do those. Draw them in standard position and then state which quadrant they lie in. All right, so we said 3 pi over 2. If it's in standard form, it would start here and go all the way around 1.5 pi. Which would fall in what quadrant? Is that a quadrant? What do you do if it's not a quadrant? Same rule as plotting points. What axis is that? The y-axis. So you write that. Okay. B. And so these are just Greek letters, FYI. Okay, don't freak out. They're fancy letters. The first one's alpha. The second one's beta. The third one is theta. Okay. Some good college prep for you. It's important to know your Greek letters when you get into fraternities and sororities. All right, so B. Standard position starts again here. This time 2 pi goes all the way back around and finishes in the same spot. What quadrant's that? X-axis. And then the last one, 7 pi over 4. So that's not one of the ones we talked about, okay? What is 7 over 4 in mixed number form? 1 and 3/4. So we said 1 pi, 1 and 3/4. We said 1 pi would be here, right? 1.5 would take me here. 2 is too far, which means it's halfway between 1.5 and 2, or here. What quadrant is that? Fourth. So if it is not a number you recognize right off the top, obviously I would put it in mixed number format. And then figure out, does it fall in between 0.5, a half and 1, 1 and 1.5, or 1.5 and 2. And that's going to place you in whichever quadrant it's supposed to be. Questions so far? Yep. All right, coterminal angles are angles in standard position that have the same terminal side. So if I asked you to graph pi over 2, and then I asked you to graph 5 pi over 2. Pi over 2 would be here. 5 pi over 2 is 2 1/2 pi, which means I'd go all the way around to 2 and then double back again to a half. These are called coterminal angles. So without their arrows, they look exactly the same. They have the same start and the same finish. The difference is how many times around they go. To find coterminal angles when we're in radians, because that's where we're going to start, you would add and subtract 2 pi. So if I wanted to get a positive positive coterminal angle, I will add 2 pi to my number until it's positive. If I want a negative coterminal angle, I would subtract 2 pi. And your answer should be negative. So you might need to do that more than once. Like if I had a negative 5 pi and I wanted a positive coterminal angle, if I had negative 5 pi and I wanted a positive coterminal angle, if I add 2 pi, I'm still negative, right? I have to do it again, and I'm still negative. I would have to keep going until that was a positive angle. So you might have to do it more than once. And the same thing if it's negative. So if I said that my initial one is 3 pi and I want a negative coterminal angle, the first time I subtract 2 pi, it's still positive. I'd have to do it again to make it negative. So when you write answers for positive coterminal angles, they should be positive. And negative coterminal angles should be negative.
So you could choose which one you...
All right, so this says find 2 positive and negative angles. We're just going to make it 1. Just find 1 positive and 1 negative angle. If I had to find 2, I would just continue to do the same process I already did. So for my positive coterminal angle here, I'm going to add 2 pi. And then we get to get really good at doing quick fractions, right? Because I need to change that so it has the same denominator. So 2 pi over 4 is the same thing. 2 pi over 1 is the same thing as, 8 pi over 4. And this becomes 5 pi over 4. That is a positive angle, so that's my positive coterminal angle.
So you need 2?
No, I said change it just so it's 1. As long as you know how to do it once, you know how to do it twice. Then negative 3 pi over 4. To find a negative coterminal angle, I'm going to do minus 2 pi, and we just said that that is 8 pi over 4. And I get negative 11 pi over 4. There's 1 positive and 1 negative. If it wanted 2, I would just add the 2 pi again and subtract the 2 pi again.
So you're always going to have 2 answers.
If it asks for 1 positive, 1 negative. If it just said 1 positive, you only need that 1. Good so far? Yep.
Isn't it negative 3 plus 2?
Negative 3 plus 8. But we changed 2 pi to be 8 pi over 4. So this 8 pi over 4 would be negative 3 plus 8. Yeah. When you graph them, remember they should overlap. So that's one way you could check it. And then B, 5 pi over 6, add 2 pi to it. Now my denominator needs to become 6. So this is 12 pi over 6, and I get 17 pi over 6. That's my positive coterminal. And then 5 pi over 6 minus 12 pi over 6. And I get negative 7 pi over 6. There's my negative coterminal. Again, on a graph, they would look the same. The terminal and the initial side would look the same. If you had the arrows, your arrows would loop around a different amount of times. That's all. All right, so this, now we're in degrees. So we're overlapping the 2, okay? Which in a moment we're going to talk about how you would get from one to the other. But if you think about your 4 quadrant angles that we talked about with the radians, we also have those 4 degrees. So this is 0. Straight up and down is 90, which obviously should make sense. That's a right angle. To the left is 180, which is a straight line. All the way down is 270, and then back around to the right would be 360, because there's 360 degrees in a circle. So again, those are the 4 quadrant angles that I expect you to know so far. Eventually we're going to fill in the rest of those, but not yet. Those are positive. Negative goes around the other way, so it goes clockwise, which means that this is your 0. This would be a negative 90. This is a negative 180. This is a negative 270, and then this would double back around to be a negative 360. So positive goes around counterclockwise, negative goes clockwise. And coterminal with angles in degrees, instead of adding 2 pi, we add the equivalent of 2 pi, which is 360 degrees. So if I want to find positive, I would add the 360. Want to find negative, I would subtract the 360. And same rules apply. If it's still not positive, even after I've added the 360, I have to do it again. So everything we do in radians, we can also do in degrees. I had if you think about it, if I had negative 460 degrees, right, and I wanted a positive coterminal angle, if I add 360 to this, I end up with negative 100.
Yeah.
So that's actually a negative coterminal angle. You could give that as an answer for a negative coterminal, okay, but it's not positive yet. I'd have to add the 360 again, and I'd get my positive 260, and that's my positive.
Okay.
So this would be a negative coterminal, and this would be a positive coterminal. So it doesn't mean you always have to subtract to get a negative or add to get a positive, depending on what it is. And then we learn to convert. So the conversion from angle in in degrees to radians, you would take the angle measure and multiply it times pi over 180. To convert from radians to degrees, you would take the angle measure and multiply it times 180 over pi. Ian.
Can you go back to the last one?
Mm-hmm. All right, we're going to skip this. I'll go back to this on Monday. But for right now, what we just need to do is learn how to convert. So we're going to convert from the angle to radians and degrees to radians and radians to degrees. Now be very careful here, because people assume that radians have to have pi in them. That's not the case. If I just told you that 2.3 was an angle measurement, without the degree symbol, that is a radian. So degrees has to have degrees, but radians does not have to have pi. Commonly it has pi, but there are, 2.3 is 2.3 radians. And it's not going to tell you that, but it's not going to have a degree symbol, and that's how you've got to know the difference. Okay? So if I want to convert 30 into radians, I'm going to multiply this times pi over 180. And then I can cancel my zeros. 3 goes into 18 6 times, and I get pi over 6. So that's radians. Go to B, and this is in radians, and I want to go to degrees. So I'm going to multiply by 180 over pi. The pi's cancel, and 2 goes into 180 90 times. So this is 90, and again, degrees. So you've got to differentiate between the radians and the degrees, and that's how you do it. C, 160 degrees. So I multiply times pi over 180. I can cancel through the zeros, and then this would be 8 and 9, and I'd get 8 pi over 9. Or 8 9 pi. It doesn't matter how you write that. But keep it exact. Don't try to make that into a decimal that's rounded. And then the last one, 3 pi over 4. This is in radians, so I'm going to multiply times 180 over pi. The pi's cancel. 4 goes in 180 45 times. 3 times 45 is 135 degrees.
What was it? 3 times 45?
Because the 4 goes into the 180 45 times.
Oh.
Make it as simple as you can. You can multiply straight across and then reduce, but in my opinion, just keep it as small numbers as you possibly can. Because again, just like before, sometimes you'll have calculators with this stuff and sometimes you won't.
Just plug in the